What if everything we thought we knew about the universe was wrong? 400 years ago, a simple tube of glass changed humanity forever. One man lifted it toward the night sky, and suddenly, Earth was no longer the center of everything. Today, another telescope floats far beyond our world, unfolding its golden mirror in the silence of space, searching for the very first light of creation. From Galileo's fragile lenses to the James Webb Space Telescope, this is not just a story of technology. It is a story of human courage, curiosity, and doubt. For centuries, we have asked the same haunting question: what is really out there? And perhaps more importantly, what does it mean for us? This journey is about more than stars and galaxies. It is about the bravery to question, the humility to learn, and the wonder that keeps us looking up. Stay with us until the very end, because the final discovery may change the way you see the universe and yourself. If this kind of storytelling speaks to you, subscribe and join us. We're just getting started, and the cosmos is waiting. Long before telescopes explored galaxies, their story began with something far more ordinary. In the early 1600s, in the Netherlands, a modest eyeglass maker named Hans Lippershey was experimenting with pieces of glass. Without realizing, he was about to change humanity's relationship with the sky. By placing two different lenses inside a simple wooden tube, Lippershey discovered something remarkable. A curved front lens gathered incoming light, bending it inward. A second lens reshaped that light, spreading it back out and enlarging the image seen by the human eye. This bending of light, refraction, was the quiet principle behind a powerful new idea. At first, this invention had nothing to do with stars. It was designed to spot distant ships, to gain advantage at sea, and to serve military needs. Yet within this humble tool lay the seed of something far greater. A device built for earthly control would soon unlock the heavens, proving that even the smallest inventions can lead to the largest discoveries. To understand how a small piece of glass could open a window to the universe, we must begin with light itself. Light does not always travel in straight lines. When it passes through glass, it can bend. This bending is called refraction, and it is the foundation of refracting telescopes. This type of telescope relies on two main lenses. The front lens is a convex lens, curved outward. As light from distant stars enters the telescope, this lens gathers the incoming rays and forces them to converge toward a single point. If you have ever used a magnifying glass to focus sunlight onto a small spot, watching it grow hot enough to burn paper, you have seen this principle in action. The second lens, placed at the back, is a concave lens. Its role is not to collect light, but to spread the concentrated rays back out. By doing so, it transforms the focused light into a larger image that the human eye can clearly observe. Put simply, the first lens collects light, and the second lens expands it. Together, they create the illusion of closeness, turning tiny, distant points of light into worlds with shape, detail, and structure. From these simple principles of light, humanity learned how to see far beyond the natural limits of the human eye. The true revolution began when Galileo appeared. Without ever seeing the Dutch instruments firsthand, Galileo built his own version of the telescope in just a few days. But he did not stop at imitation. He improved it. While early telescopes magnified only 3 times, Galileo's design reached an astonishing 20x magnification, a level unheard of at the time. With this new tool in his hands, he turned it toward the night sky. When Galileo observed the moon, he was stunned. What he saw was not a smooth, flawless sphere as described by Aristotle. Instead, the lunar surface was rough and uneven, marked by mountains, valleys, and deep craters. The moon was not a perfect heavenly object made of divine material. It looked strikingly similar to Earth. This discovery did more than rewrite our understanding of the moon. It shattered a belief that had stood unchallenged for over 2,000 years. The idea that celestial bodies were perfect and unchanging. For the first time in history, humanity was forced to confront a terrifying yet liberating truth. The sky was not sacred and separate from Earth, and the universe was not built around human beliefs. And with that realization, the foundations of an old worldview began to crumble. After the moon, Galileo turned his telescope toward another target in the night sky: Jupiter. He could not yet see the surface of this massive planet in detail, but he noticed something far more important. Surrounding Jupiter were 4 small points of light, appearing in different positions each night. At first, they looked like faint stars. But after days of careful observation, a clear pattern emerged. These points were moving. They were orbiting Jupiter. They were moons. This discovery dealt a devastating blow to the geocentric worldview. If some celestial bodies did not revolve around Earth, then Earth could no longer be the center of all motion in the universe. From this moment, a chain of logic began to unfold, one that could not be undone. If the moon orbits Earth and Jupiter's moons orbit Jupiter, then perhaps smaller bodies naturally orbit larger ones. And if that is true, then Earth itself could be orbiting the Sun. For the first time, scientific reasoning based on observation and logic began to replace beliefs that had been accepted simply because they had endured for centuries. The universe was no longer governed by tradition. It was beginning to obey evidence. Truth, however, always comes with a cost. As Galileo shared his discoveries, he did not face curiosity alone. He faced power. Galileo's conclusions directly challenged the authority of the Catholic Church, whose teachings placed Earth at the center of creation. To question that idea was not merely scientific rebellion, it was considered heresy. He was summoned before the Roman Inquisition, accused of spreading dangerous ideas that contradicted Scripture. In the end, Galileo was forced to publicly renounce his views. His punishment was not execution, but something quieter and crueler: house arrest for the final 10 years of his life. He was silenced, isolated, and cut off from the world he had tried to enlighten. The consequences reached far beyond one man. Witnessing Galileo's fate, many scientists chose caution over truth, delaying open support for the sun-centered model for decades. Yet even confined, Galileo continued to think, write, and question. His body was restrained, but his ideas were not, and history would eventually prove that truth, though suppressed, cannot remain hidden forever. While debates about the structure of the universe were still unfolding, a quieter yet decisive breakthrough emerged, this time driven by engineering rather than philosophy. The mind behind it was Isaac Newton. Newton recognized a major limitation of refracting telescopes. Glass lenses were extremely difficult to manufacture at large sizes. They were heavy, prone to distortion, and often suffered from color aberrations. Instead of refining lenses further, Newton proposed a bold alternative: using mirrors. In a reflecting telescope, light is not bent as it passes through glass. Instead, it is reflected by a curved mirror placed at the base of the tube. This mirror gathers incoming light and focuses it to a single point where the image is directed toward the eyepiece. This design offered significant advantages. Mirrors could be made larger, lighter, and at lower cost, while reducing many optical imperfections. Although reflecting telescopes have drawbacks, such as a slight loss of sharpness caused by secondary mirrors, their ability to collect far more light proved decisive. For this reason, reflecting telescopes quickly became the dominant design in astronomy, paving the way for ever larger, more powerful instruments that would push human vision deeper into the cosmos. In the early 20th century, humanity faced a shocking realization: the universe was far larger than anyone had ever imagined. At the center of this revelation stood Edwin Hubble. Using one of the most powerful telescopes of his time, Hubble focused his attention on a hazy object known as the Andromeda Nebula. Many believed it was simply a cloud of gas within our own galaxy. But inside Andromeda, Hubble identified a special type of star: Cepheid variable stars. These stars brighten and dim in a precise, predictable rhythm. By measuring that rhythm, astronomers can calculate their true brightness and therefore their distance. When Hubble did the math, the result was staggering. Andromeda was far too distant to belong to the Milky Way. It was an entirely separate galaxy, containing billions of stars of its own. The universe was not made of one galaxy, but countless ones. The shock did not end there. Hubble soon discovered that nearly all galaxies were moving away from us, and the farther they were, the faster they receded. The universe was not static. It was expanding. This observation provided the first strong scientific foundation for the Big Bang theory. If the universe is expanding today, then in the distant past, everything must have been much closer together. For the first time, humanity glimpsed the true scale and history of the cosmos, and realized that the universe was not only vast, it had a beginning. Even as ground-based telescopes grew larger and more powerful, they remained limited by Earth itself. The atmosphere distorts incoming light, artificial illumination creates interference, and the heat of our planet obscures the faint signals arriving from the distant universe. To see farther, humanity had to leave the ground behind. That is why the Hubble Space Telescope was placed into orbit. From above Earth's atmosphere, Hubble can observe the universe across multiple regions of the light spectrum, from ultraviolet and visible light to near-infrared. This capability is crucial because light does more than form images. It carries information across time. As light travels for billions of years through an expanding universe, its wavelength stretches, shifting gradually toward the infrared. By studying this effect, astronomers were able to determine the age of the universe, approximately 13.8 billion years. But Hubble did not stop at answering how old the universe is. Its observations also revealed deeper mysteries, evidence for dark matter and dark energy, invisible forces that govern the motion of galaxies and shape the ultimate fate of the cosmos. For the first time, humanity was not only seeing farther into space, it was beginning to look back through time itself. To look even deeper into the universe's past, humanity needed a step bolder than anything before it. That step became the James Webb Space Telescope. Unlike Hubble, which orbits Earth, James Webb was placed at Lagrange point L2, about 1.5 million kilometers from our planet. A rare position where the gravitational pull of Earth and the Sun nearly balance. From there, the telescope can remain hidden in darkness, shielded from heat and stray light, allowing it to listen for the oldest signals in the cosmos. James Webb carries a massive 6.5-meter mirror assembled from foldable hexagonal segments. In front of it lies a multi-layer sun shield, protecting the telescope from the sun's heat. This design enables Webb to observe deep infrared light, the ancient glow of the first stars and galaxies formed shortly after the Big Bang. Yet the most remarkable thing about James Webb is not its size or its technology. It does not deliver final answers. Instead, every new image and every new dataset raises more questions. And perhaps that is the true beauty of science, not to end curiosity, but to sustain it. From Galileo to James Webb, humanity has never stopped asking questions. And as long as we remain curious, as long as we dare to look up at the sky, the journey of exploring the universe and ourselves will continue. The future of science does not lie in what we already know, but in the questions we have not yet dared to ask.